Hello everyone. Can you hear me? Can everyone hear me? Great. Thanks for joining here. Sab theek thaak? Okay, great. So we'll start with my session, which is beyond passwords. Let's get rid of passwords. Let's go passwordless. So before we start the session, a bit about me. So I've been working on our identity and access management product in miniOrange for past 7 years. I'm leading a team which is responsible for integrating MFA into multiple services. I'm part of a team which is responsible for integrating FIDO2 and passkeys into our products. And I hate passwords. Just hate them. Just hate managing them. Just hate passwords. But why so? Right? So let me ask a question. How many of you use your Face ID or your fingerprint to log in to apps or sites? Can I get a show of hands? Right? Yeah, you're already in my gang then. So that's what passwordless is. You're not using your passwords to log in. Okay, man. Is it better now? Okay. Sorry. So, so first we'll go over what is the problem with the passwords. Right? Itna kya bura hai? So first problem is now the passwords mainly rely on what you know, right? They rely on what you know. They rely on your knowledge. If anyone can know your password, they can log into your site, they can log into your account. So that's their first problem. It's not who you are, it's what you know. The second problem is it has a high risk of identity theft, right? We have seen that in the past. The passwords are leaked, right? There can be a man-in-the-middle attack. So they are vulnerable to that. They can be easily hacked by brute force or dictionary attacks. We all know how much we love to keep our passwords admin123, right? It's easy to guess. And finally, they can be leaked in data breaches. So am I still visible? Okay. So they can be leaked in data breaches. They have been leaked in data breaches. We hear news about 3 billion or 800 million passwords breached. I think वो number थोड़ा बढ़ाते हैं to show how many users they had. So to solve this problem, they came up with 2FA, the second factor of authentication. To use OTP on your SMS, on your email, to use your authenticators, push notifications, right? They use that. But now there was some additional problem with that. It's safe, right? It's safe. But again, it relies on what you have, what device you have, what device you are using. If I have your phone, I can still log in, right? It's again not who you are. It doesn't contain your identity. 2FA was required. 2FA is required everywhere now because of the password theft. So you need to use it. You can't skip it. It has a poor user experience. I enter my password first, then I enter my 2FA, right? Kitna time kiske paas hai? Again, it doesn't contain your identity. 2FA, your OTP, it can't really say whom that OTP came from, right? It's just a number. And if you're using physical keys, if you're using hardware tokens or your devices, you can always lose them, right? It's something you have to possess. So what we saw in James Bond movies, they have this USB which is always in their neck and they always lose it somehow. So that was a problem with 2FA. So what the FIDO2 Alliance, it is an alliance which maintains security, which comes up with standards. What they came up with was, okay, why use passwords then? If you don't trust the passwords that you had to implement 2FA, don't just use passwords, right? You have biometric authentication now. So they came up with passkeys. All of your devices, whether you are using a Microsoft device, an Apple device or a Google device, it supports passkeys. So what are the benefits? First of all, it relies on who you are. A passkey can, for guarantee, say that it's you who is logging in. It contains your identity, right? You can log in without your username, your password, or your 2FA. Just a simple biometric authentication and you're logged in. You just have to provide your Face ID or your fingerprint. Easy, right? It never leaves your device. Now this is too good to be true, but it is true. It is a kind of a password which will never leave your device. All your passwords and your 2FA keys, they go to a server, right, over the network. your private key never goes. Your passkey never goes over the network. It is always on your device. It uses your biometric authentication, right? We have seen in movies how difficult it is to replicate that. You will need someone's eye or hand or I don't know. And it's right now built at all major OSs and browsers. All your browsers, whether it's Chrome, Firefox, all your OS, whether it's Windows or your Mac OS or Linux right now as well, they all support passkeys. So it has a cross-device compatibility. So what exactly is a passkey? So passkeys.io defines passkey as a discoverable web authent credential. Really good at security, really bad at defining things. So let's see what it really means. Discoverable simply means that you don't have to enter your username. A website on which you are logging in, if you are logging in with your passkey, it will know if you have a passkey to log into that website. So it's discoverable. WebAuthn is simply a browser API which can interact with your device and use your device's authenticator. Like if you are on your site, that site using WebAuthn API can use your Face ID, which is on your device, or it can use your Windows Hello fingerprint. And a credential, this credential is actually your passkey. It is a private key which is stored on your device. This WebAuthn API uses your authenticator to create a private key which sits on your device and it authenticates you from there, from the device itself. So how do passkeys work? Right, that's the real question. I mean, it never leaves your device. So how does that work? So to understand that, we'll have to first go into how public key cryptography works. So there was a cryptography session just before me. So I think you will have a bit of an idea, but I'll just give a basic idea of how public key cryptography works. So let's say I have a message, right? Let's say I have a document, I need to send it to the server. So I'll have a key pair, a private key which is with me, a public key which I can send to anyone. It does me no harm. So I can send it to the server. A server has my public key, it's public, and I have my private. So I have this message, I'll hash it. I'll apply any hashing algorithm which is available in the market. Right? Okay, it created a hash. My document, it converted it into a text, a ciphertext. Now I encrypt this hash using my private key, right? And I create a digital signature. Digital signature is nothing but my document plus my encrypted hash. Now it is safe to send over to the network. I send it over to the network, to my server, to any third party. Now they need to know that it was sent by me and it was not changed in between. So what the server does is it will first of all, my document, like my original document, it will hash it again. A hash will be generated. If the same hash algorithm is used, it will be same as the hash which I generated first. Now I have an encrypted hash as well with my document. So it will use my public key to decrypt that. Now it has two hashes. They should be similar. And if they are same, it will know that it was not meddled with. It was sent by me. Right? So that's how public key cryptography works. But for this session, I just want you to remember this. Private key sign करता है, public key verify करता है. That's all you need to know. Private key, I have a private key, I'll get a message, I'll sign it, I'll send it over. I won't send my private key. It will stay with me. And the server will just have to use my public key to verify it. And that's how public key cryptography works. And that is exactly how the passkey works. So let's see. First of all, you'll have to create a passkey, right? You're on a site, you're logged in, you want to create a passkey with which you can later on log in to your site. So this is an example form which I have created. If I click on the create passkey button here, it should ask me for my biometric and it should just say, okay, your passkey is created. I don't want to do anything else than just provide my fingerprint, right? So let's see how that works. I clicked on create passkey. It asks me for my PIN or fingerprint. I provided my fingerprint and it said, okay, your passkey has been saved, right? Now you have to focus, you have to give attention to when it says that your passkey has been saved. It will tell you that it has been saved for this site and it has been saved for this username. So your device will have a unique passkey for all the sites you go and all the usernames you log in with. all those passkeys are stored on your device, right? Those are unique. Your passkeys are not shared between the sites. So let's see how this works. Now this will get a bit more technical. I'll show you how exactly it goes from the client to the server. So this is me, the user, right? Ankit. I'll just click on register. That's all I do. I'm lazy. The client, it will ask the server to just give it a challenge. Right? Just give me any random string, any document I can sign. Okay, and I don't want to generate it. The server will say, okay, this is ABCD1234, not so random, but please sign it. Okay, great, I can do it. Now the client, which is my browser, will ask my device authenticator, right? My device authenticator like Face ID or biometric, it will ask it to, just sign it, man. And it can do it using the WebAuthn API, which I talked about earlier. So the WebAuthn API, now my authenticator will say, okay, I can do it, but I just need some kind of verification. Okay, just give me a fingerprint. I gave that. Okay, I gave my fingerprint like I did there when I clicked on create passkey. Said, okay, I know you are you. So now I can just generate a public key and a private key. My authenticator will do that in the backend. It will give me a private key and a public key. And it will sign that random challenge which the server sent me. It will sign that. It will say, okay, this is your signed challenge. This is the username for which I created the public key and private key. And this is a credential ID because, everything needs an ID to be identified. So my browser is now happy. It's like, okay, authenticator, your job is done. So my browser will now send it over to my server. It will say, okay, this is the public key which I got from the authenticator, and this is a signed message which authenticator gave me. Can you please verify? Because between client and server, the challenge can change, right? So to authenticate that it wasn't changed at all, it will verify the signature. The public key can verify the signature, the private key has signed. If they say, okay, I can verify that this challenge is correct, the challenge I gave you, it is perfectly signed, and the public key which you gave me, it is working. So what the server will do, it will save my public key against my username. The website which I'm logging into, it will save my public key against my username, and it will ask my device to save the private key against my username and the website name. Right, now I have the passkey created. I have my private key on the place and then my public key on the place. So this is how the registration works in the backend. Now I have to use it to authenticate. So this is an example form when I'm trying to authenticate. Now notice when I click on username, the website using the WebAuthn API is able to know that I have a passkey saved for this username on this device. So it will just suggest me. So this is what I mean by discoverable. Before passkeys, when only WebAuthn was used, this was not there. You can't discover it, right? So you had to enter your username. So now I don't need to. So if I just click on it, it will ask me for my fingerprint and I will logged in. Simple as that. Let's see how that works. So I clicked on my username. It will ask me for my fingerprint. And once I provide my fingerprint, it will be like, okay, man, you can get in. Right? Simple as that. Now how this works in the backend is the similar thing. You have to get a challenge, you have to sign a challenge, and you have to ask the server to verify the challenge. All you have to do, you have a private key to sign in, you have a public key on the server to verify it. Your private key doesn't have to, leave your device. Simple as that. And that's all we do. Again, when I clicked on sign in, right, the client using the WebAuthn API checked if I have a passkey. It saw that I have a passkey. So it asked the server, give me a challenge, right? I'll find something. I'm in a mood. So it's like, okay, this is a random challenge which is similar to the previous challenge. It doesn't happen in real life. I'm too lazy to write another challenge here. It will be a different challenge. It will be a different string. It will be maybe for lack of my imagination, EFGS 4567. Could be that. So client is like, okay, authenticator, you have the passkey, right? Can you please sign this? Authenticator will be like, okay, I can sign this, but I just need some kind of verification from the user, right? I need some kind of gesture. This gesture is the key. So I have to provide my fingerprint again to allow the authenticator to sign the challenge. I provided my fingerprint, it verified, okay, fingerprint is correct. The device itself will verify it. And now it can access my private key after getting my fingerprint. So it has my private key stored in a vault on a device. It can now access my private key and sign the challenge. It cannot access my private key unless I provide the biometric authentication. So now it can sign the challenge. Again, it will send the signed challenge, the credential ID, and the username for which it signed to the browser. You can use this for authentication. Browser will be like, okay, so browser will send this time the username and the signed challenge over to the server. Now, notice that when we were registering, the browser didn't have to send the username because I was already logged in. I was just waiting my passkey. But this time I have to log in, so it has to send a username over to server because the server will use that username to fetch my public key, which it has saved with it. So it will say, okay, for Ankit username, I had this public key. I'll see if this public key can verify the message we have sent. Then I'll know that it has been signed by the correct private key. Right? Uska judwa bhai. Once it's verified, it can just sign me in because it doesn't need to verify anything else. It knows that at some point I have provided my biometric authentication. I have allowed this device to sign this challenge. Right? It cannot sign the challenge without my permission. So that's how the registration, the creation of passkey and the authentication of passkeys work. Simple as that. And this is how we got rid of passwords. So I would suggest if you see any option to log in with your biometric on any site or app, please use that. That is a better approach. Now the first question just comes to mind, what if I lose my device? I use this walk who provide my Face ID and log into the site. Now I lost this phone, as I always do. Now what do I do? How do I log into this site? I don't even have a password to this site. How do I log in? To solve that problem, so far Apple and Google, who are in the FIDO alliance, they have come up with a way to sync your passkeys across the devices. Because you log in with your Apple account or Google account to those devices, right? So Microsoft is on the way to do that. And that's how, even if you lose your device, you get a new device, you log in with your Apple ID, your passkeys will still work because it is stored in their secure password vaults. Even if your passkey goes away, not a problem because it can only sign by using your biometric, right? So what will they need? Your eye or your hand, which they won't get because we are not in James Bond, right? So what are the challenges? But there are still some challenges. It is a fairly new standard. It is a fairly new technology. So obviously, legacy systems, they don't support it. And we use a lot of legacy systems. We use the Oracle applications and plethora of native apps, desktop apps, which are still legacy. And they don't support passkeys right now. You still need to use the username and password to, log in there. Because passkeys is a utopia, but as long as someone implements it. So that's the second challenge, the developer adoption, right? As you saw, it was still a bit complicated, right? You have to use all the signing and verification and everything. So it is still a bit complicated to implement, and not a lot of sites are still implementing it, right? So an awareness is needed there. But that's one problem. If you have a site, if you need to implement passkey login, it is still a bit complicated. And then even if you implement it, right, you have to do compatibility testing across the devices, right? This is where you can use any IAM solution which supports passkeys. So you can directly connect your site using single sign-on to that IAM solution, and you can use the passkey there. That solution is already tested with everything. So you can use that to overcome these challenges. And now that the passkeys adoption is growing, these challenges will go away pretty soon. So that was it. That was my session. What are the key takeaways? Passwords, not saving. Please don't use them anyhow. At least not without 2FA, please. 2FA options are pretty reliable still, but they compromise the usability, right? We have to do a lot of steps to just get into a site on a head. The passwordless authentication using passkey, more secure because the key never leaves your device. Easier because you don't have to do anything, right? You just have to provide the biometric. And it's available across all major OS and browsers. Single sign-on with Fido to supported IAM, as I said in my last point, will be helpful in overcoming some challenges in integration of passkeys, which you can use. So I would suggest just when you go from here, just read about it a bit. See, you can just be aware and alert about what all sites, what all apps are supporting the login with that were login with the fingerprint, right? These are the references I took. I took mainly from passkeys.io, what is webworking on miniOrange site, and the passkeys.dev, which I used to create the form, which I showed. And that's my session, guys. So if you have any questions, I'll be happy to take them. If you want to provide any feedback here, you can just, scan this QR code and provide it to me. So yeah, any questions?
No. Yes. The not image in. Does that mean that if passkeys get acceptance across the industry, YubiKey will be out of business?
I think YubiKey is also coming up with biometric authentications to be accepted into the passkey standard. Into the passwordless standard. So I don't think YubiKeys will be out because not all the machines right now support biometric authentication.
Yeah, I agree. But like you said, Google will sync passkeys across devices. Apple might sync it. Subsequently, Microsoft might sync it. What happens if you use an iPhone, Android tablet? Generally what happens is people use different kinds of devices all at the same time. So if I'm logging in with an Android, I have to recreate my passkey from the Android device, correct? So that's a major drawback. You have people who might use a MacBook and have an Android phone, might have an iPhone, use a Windows machine. So in that case, passkeys sort of, make doubles your work. But if you have a single YubiKey, that will work across all three devices.
Yes, that's what I said. So, but still won't work in mobile devices maybe. But yeah, still, that's why the security keys are used with biometric authentication because they can work with each and every device. And if you are connected to a server, you probably won't have authenticator there. So yes, YubiKeys are not going away. So, any other questions? Yeah, please.
So typically every certificate have XYZ in extensions. So in this case, what is the user specific information is when you the public certificate?
It's just your user. Just the username which you are using. So here I use Ankit. That's all. So in the certificate, no information is going. That's about it. It's a random message. It can be any.
No. So you have to know the subject identifier. I see. So many of say typically in certificate use the common names or years to object that ways. Some too specific to your servers and generally when we use public priorities. So here to identify that this violating actually translates to this user information. Is it just the user name or something instances?
So no, actually in the certificate, let's say in this example I took Microsoft Hello, right? Windows Hello. So the subject is your name and everything will be related to Microsoft some domain. I'm assuming because it is creating the public and private key, it is using its own domain authority to generate that. It will store that key against my username in its own vault. There will be some wrapping there with my username and my site name, but it won't have any information about me in the certificate because it doesn't need to. That's why when we are registering, the server has to store my public key against my username because if the certificate hide it, it won't need to. But I think that's also not secure. So that's why the certificate just contains information about the certificate authority, which only Microsoft did that. In this case, Face ID, case it can be Apple, but not the username.
You didn't need of new expansion or an extension for this.
Yeah, but I still think certificates are not so secure for username or keeping username. So they keep a mapping if their password vault on the server, but it is not transferred over the network.
We will need it to happen out.
Okay, I did was less about the E2E.
You talked about the legacy authentication systems, right? With the Oracle and everything. They are not very usual change. So, what is the impact basically? Which is just till now we were storing the credentials, login and password credentials. Now we are not going to store those things. So even if they remove, whether is it easily adaptable for them, like banks can easily implement such kind of features. So why they are so reluctant or they are not aware of this integral actually?
So when I said legacy systems, I mainly meant the self-hosted systems which these companies provide. There's a huge push to cloud right now. So they are majorly working on that. So even if you see the banks, if you open any of your banks app, it will have a biometric authentication in it. So they have already done it there. But let's say Oracle, if you talk about Oracle EBS, let's say it's a self-hosted system which is used by some big industries, but there's a push to cloud now. So they are not really heavily working on development front on that. So that is the only reason they are not adopting it right now.
Thank you.
Peace out. Let's do it. Very good hours.
Yeah. So, like, the first step, the personal step, would include the biometric verification, right? So, what is the new AI generated master tricks and abilities to get their way around this process? How would that, I think, take some measure in that?
So if I'm right, you are talking about the deep fake AI, which can
From master fingerprint, I think.
the master fingerprint, which can replicate anything in real time. Sorry, I don't know much about that topic, but I don't think till now it has been possible. But yes, if the biometric authentication application is possible, maybe this won't be safe, and or maybe they will put in more stricter measures there at that point. Right now, the focus, because this has not been done yet, the focus is on making it more and more usable with the same, if not higher security. Okay? But later on, might be possible. We'll have to look down.
Then,
So you can't go, you do the cut.
What made this natural? So, what is the pass? Is it a biometric key? No, it's not a biometric key. It's just a simple private key which is used for signing. It is created after you provide biometric authentication. So, you are kind of giving a permission. A passkey is simply, as I said in my previous slides of credentials, it is simply a private key which is stored on your device, whose public key part is stored on the server. So, and yeah, I can find that out with all the animations which are in it. But yeah, it is just a private key which is stored against your username and your browsing DOM. That's it. That's all it is. So yeah, in that new device, how it verifies whether the passkey is yours. Yep. So on each device where you want to use a passkey, if it is not same, you have to create it. So for creation, you have to provide the biometric authentication first, and then it is stored against your username and password. And when you are trying to log in and you provide biometric again, it has a permission to look into your password word for a passkey of this username and side name, which your authenticator does. So you see, this one device is storing it. This one device is searching for it. It is like having one modem looking for the files. It's safe as the heck, you can say. So, and it will always require first your verification to go. So that's how it goes. There's a mapping there for master window. Okay, there's a question there. I think we still have some time.
So, hello sir. Sir, when we verify using biometric or Face ID, so our Face ID is not exactly used. Our Face ID is generated into something, then it is hashed, then it is encrypted. So, what is it generated into?
So, okay, so it was not covered in that because it went a bit more advanced, but whenever you provide your Face ID, it takes some points, some inputs from your Face ID and creates a fingerprint hash. Is we call it fingerprint hash is basically a string which it creates, and it uses that key. So as you learned in the cryptography, it uses that key to create a hash. It matches both the hashes and then it verifies that, okay, because when you created it, you provided biometric authentication, right? At that time, a key was created, using it, a hash was created. It creates the same hash again. Because this is an irreversible process, you can't decrypt a hash. So it creates the same hash again, and it sees if both match, and then it picks up your credit. I'm sticking out. It will.
So, sir, what if the fingerprint hash you are telling, what if that gets out?
If that gets out, right now it's not a problem. So that's why in the alliance, the Freedom Alliance, which I talked about, only 3 major platforms have come in so far to implement it themselves. So you see, when I did the biometric authentication here, I wasn't doing anything. The browser wasn't doing anything. Even my server wasn't doing anything. It was completely my OS, right? Even if it gets out, first of all, it won't get out because we are trusting our security to our OS. Even if it gets out, you have to provide it to something. Your OS won't be accepting it unless it's prompted. So, and it generally doesn't get out. You have to get a key. So if you attended the last session of cryptography, you'll understand the asymmetric encryption key which was provided. In 25 years, there have been only like 4 one out of the 14 different data it was caught in the last one. So it's as secure as that. I mean, hypothetically, good to think about, but so far it hasn't been.
It is not our problem now, as of here.
Yes, we'll sell it. It had never been your problem. It had been the server's problem. Now it's not your server's problem. They have delegated their problem to these 3 major players, and more will be joining in the alliance and will be adopting the passkeys. So more and more will be taking it up. I think Linux is not there yet, but if you are using your browser on a DM system, you can always, on your phone, it will generate a QR code which you can scan, and then you can use your phone's Face ID key. So yeah, it's not your problem. Thank you.
Thank you.
Are we taking at least we are okay. I think we can. I think I can take one class. Then
there are very good questions. One question is, I'm just adding to his question. You just mentioned these are creating some fingerprint hash values. Okay, so I will talk about the loopholes in this password. I just wanted to know, are these fingerprint hash values figures? Yeah. So are these fingerprint hash values for passkeys prone to the birthday attack as well?
which attack?
Birthday attack.
Sorry, I'm not aware about that attack.
Okay, great. Fine, I'll pass.
Sorry. I'm so sorry, but I'll be happy to talk about it.
With the quick use, this Mac, in an Apple device, very top, they are creating their own in the offering. Like every people in the browser say that they have their own devices. If one the device is being 7 I can sign on multiple devices. What is with some the reverse side? If one device is in track, I can entirely won't be a third.
Oh no, because your key is on your device. So even if you got it, you haven't got it for all the other devices. I know you are referring to the point I said about the syncing of the keys. But yeah, that security is up to them. I think it's robust enough for now for them to be able to share it, because it wasn't shared earlier because of the security concerns. But I think that has been approved now. So, but I know what you're saying is correct. If the private key itself gets out from the cloud sync, it can affect, but it will still need your biometric authentication. I think.
It's one story with a line or something.
Yes, it when the first time you register it, at that time it is stored. It is not stored as such. It creates a fingerprint which is that used to create a head, which is stored here.
So we store the fingerprint, a biometric fingerprint, in a key store or trust store, whatever in the device, right? So what if, like, after 2 days I met an accident and my hand and fingers are smashed. Now we lose the fingerprint. Now it's not generated, right? So what happens that at that time? At that time, you will have to go through the reset process and you'll have to reset again. How do I know? I messed up this finger somewhere around last year and I had to register it again at that point. Because then, but again, your fingerprints, I'll just add to it, is a bit of a scientific fact. Even if your finger is cut, messed up, your fingerprint is not that. It's not on your skin. It's a contour which is inside. So it comes up eventually. But after age of 60, the fingerprints. After age of 60, we lose the fingerprints. Yeah, after age of 60. Even the other biometric, you will see that they will offset or they will deactivate, like disable those. Because a lot of time women or anyone do household goals, they and the due to weathering or whatever, we will lose the fingerprint. So after the age of 16, I would suggest either use Face ID or the pin authenticator. Or maybe just enjoy your life, man. 60. I won't be doing after age of such. I'm not logging into anywhere. So I think that was it. If you can provide any feedback, that would be great. You can share your learnings on there. And if you want to see a demo of how this works, you can visit our Access 360 booth in the exhibition hall. Thank you so much.